Hello viewers, in today's class we are going to discuss one important problem from definite integrals involving greatest integer function, right? So here we have to find the value of this integral from 1 to e cube, and the integrand is x times greatest integer of square root of log of x, right? Now to solve this integral, what we will do, we'll use the method of substitution, right? Now let us take this integral as I, right? And here we'll take t is equal to square root of log of x, right? So here we are not writing the base e, and it is understood that the base of this logarithm is the exponential number e, right? So we'll take t is equal to square root of log x. So now we can write t square is equal to log of x, and we can now write x is equal to e raised to t square, right? So we have substituted here t is equal to square root of log x, so that x is equal to e raised to t square. So now let us differentiate both sides with respect to t. So we have dx over dt is e raised to t square, and the derivative of t square by chain rule is 2t, right? So now we can write dx is equal to 2t e raised to t square and dt, right? Okay, so now what we will do, we'll change the limits according to this substitution, right? So here the limits of integration vary from 1 to e cube. So when we have x is equal to 1, then the value of t can be obtained from this expression. So this is square root of log of 1, and log of 1 is 0. So we have here 0, right? So when x is equal to 1, t is equal to 0. Now when x is e cube, then the value of t is square root of log of e cube, right? So now we can write it as 3 log e, and log e is 1. So we have square root of 3 times of 1, that is square root of 3, right? So now here when x is e cube, the value of t is square root of 3. So now we can write this integral I in terms of t as 0 to square root of 3, because now the limits of integration are from 0 to square root of 3, and for this x we can write e raised to t square, right? And here we have the greatest integer of square root of log x, and square root of log x is t. So here we have greatest integer of t, and for dx we can now write here 2t e raised to t square and dt, right? So now we can write this integral as 0 to root 3. We have here the value of greatest integer of t, and 2t times e raised to here we have t square, and here we have e raised to t square. So we have 2 times t square here, right? So now we have to solve this integral. So now to move further, what we will do, we'll concentrate on the limits, right? See here the limits of integration varies from t is equal to 0 to t is equal to square root of 3, right? So here we have 0, and here we have 1, here we have 2, and the square root of 3, the approximate value of square root of 3 is 1.73, right? And 1.73 it lies somewhere here, right? So here we have square root of 3. So now what we will do, we'll break this integral as a sum of two integrals, right? Because here the greatest integer function is involved, and whenever we come across with greatest integer function, we always search for integers, right? So between 0 and square root of 3 we have this integer 1, right? So what we will do, will first go from 0 to 1, and the integrand is greatest integer of t, 2t e raised to 2t square dt plus, and then we'll go from 1 to square root of 3, right? So here we have greatest integer of t, 2t e raised to 2t square, and here we have dt, right? So now this I we have written this I as a sum of two integrals, right? Okay, now let us take the first integral. Now see, here t varies from 0 to 1, right? So when t lies between 0 and 1, then the value of greatest integer of t should be equal to 0, right? So here we are using the definition of greatest integer function. So when t lies between 0 and 1, then the value of greatest integer of t is 0. So here we'll have 0. So this integral becomes 0, right? Or this integral disappears here. So now this is 0 plus, and see, we have the second integral, right? And here t varies from 1 to square root of 3. So when t lies between 1 and square root of 3, then the value of greatest integer of t must be equal to 1, right? Because for all values of t which lies between 1 and square root of 3, the greatest integer of 3 must be equal to 1, right? So here we'll have 1, right? So now here we'll write 1, then we have 2t e raised to 2t square and dt, right? So now we have to solve this integral, that is from 1 to square root of 3, and we have 2t e raised to 2t square dt, right? And again here we'll make use of the method of substitution, right? So what we will do, we'll take y is equal to say 2t square, right? So we'll substitute y is equal to 2t square, so that dy over dt is equal to 4t, and we can now write dy over 2 is equal to 2t dt, right? And we can change the limits accordingly. So when t is 1, t is equal to 1, then the value of y is 2 times 1 square, that is 2, and when t is square root of 3, then y is 2 times square root of 3 square. So this is root 3 square is 3, so we have 3 to just 6, right? So when t goes from 1 to square root of 3, then y goes from 2 to 6, right? So now we can rewrite this integral as I is equal to 2 to 6 for 2t dt, right? For 2t dt we can now write dy over 2, and here we have e raised to 2t square. 2t square is y, so here we have e raised to y, right? So now we have half 2 to 6 e raised to y dy, right? And the integral of e raised to y is e raised to y, and the limits are from 2 to 6, so we have half, and now we can substitute the limits and we'll take the difference. So we have e raised to 6 minus e raised to 2, right? So the value of this integral is equal to half e raised to 6 minus e square, which can also be written as half. We can take e square common, so we have e raised to 4 minus 1, right? So this is the second form of this result, and now we'll try to express this result in terms of hyperbolic function. So viewers, we know that the definition of hyperbolic sign is given by e raised to x minus e raised to minus x over 2, right? So sin hx, which is the hyperbolic sign, is given by e raised to x minus e raised to minus x over 2. Now here take x is equal to 2, right? So when we take x is equal to 2, then we get sine of hyperbolic 2 is given by e square minus e raised to minus 2 over 2. So this is e square minus 1 over e square over 2, and we can now write sine h2 is equal to e raised to 4 minus 1 over 2e square, right? So e raised to 4 minus 1 can be written as 2e square times the hyperbolic sine of 2, right? So this expression e raised to 4 minus 1 can be replaced by this one. So we have I is equal to half e square times here we have 2e square and sine of h2, right? So hyperbolic sine of 2 here. Now this 2 and this 2 get cancelled. So I is equal to e raised to 4 sine h2, right? So this is another form of this result which is expressed in terms of hyperbolic sine, right? So viewers, this is how we can solve this integral.